Right here is a slightly more difficult circular motion problem. You have a 1 kilogram mass attached to a rod by two strings, as I've shown you here, and it is spinning around the rod in a horizontal circle. The strings are 4 meters and 3 meters long, and they're attached to the rod so that their points of attachment are 5 meters apart, as you see here. That means I've made myself a 3, 4, 5 right triangle, and that the angles that the upper string makes with the rod is 37 degrees and the lower string 53 degrees. We are going to need, since this guy is moving in a circle, we're going to need to know what the radius of the circle is. And I think you can all see by simple geometry that we have a triangle whose angle is 37 degrees and whose hypotenuse is 4 meters. And so this unknown quantity r, which we're going to need, is equal to 4 times the sine of 37, which is equal to 4 times 0.6, which is 2.4 meters. Okay, so that's the radius of the circle. Okay, choose a body. And of course, I will choose the 1 kilogram object. What are all the forces on it? Oh, one important feature that I did not tell you, and you will be able to read this when you're watching the video. The condition is that the tension in this string is equal to twice the tension in this string. Okay, and the problem is to find out how fast the 1 kilogram object is moving in its circle so that the tensions have this ratio. So all the forces on our object are its own weight, which is 10 newtons, a tension in this direction, which we'll call T, and a tension in this direction, which we'll call T2, and T2 is has the magnitude of T over 2. Okay, choose a coordinate system, and I am going to choose a coordinate system which has its x-axis horizontal and its y-axis vertical. And you can see that 37 is here and 37 is here. Choose a body. We've done that. Coordinate system, done that. We're going to resolve the forces as we go. So the sum of the forces in the y direction, that's equal to 0. There is no acceleration in the y direction. And so that's equal to t times the cosine of 37 minus t2 times the sine of 37 minus 10. And that's equal to t times 0.8 minus t over 2, that's what t2 is, times the sine of 37, which is 0.6, minus 10. So let's see what we have here. We have 0.8 minus 0.3, which is 0.5. So this is 0.5 t minus 10. And that's equal to 0. And so t is equal to 20 newtons. And for completeness, T2 is 10 newtons. Okay, so now we can say the sum of the forces in the y direction, sum of the forces in the x direction is not equal to 0, but is equal to m times v squared, v we don't know, divided by r, which we figured out above, which is 2.4. That has to be equal to, all right, let's look at the picture up here, and we see that we've got the x component of t, which is 20 times the sine of 37.6. And we also have that the T2, which we found is 10 times the cosine of 37, which is 0.8. So we have that, doing our arithmetic, we've got 12 and 8 is 20. And so V is equal to the square root of 48, just a little bit less than 7, 6.93 meters per second. That's it.